Do you know that logic gate and logic expression problems are the simplest to solve in a computer science exam? Okay, I'm going to show you using this very question. And this question is coming from the Cambridge IGCSE Computer Science Paper 2. That is for May, June 2025, the component 3. From my record, over 90% of you who watch my videos are not subscribers, and that is a staggering figure. So I want to use this opportunity to remind you to subscribe, like, share, hit the notification button, and even comment. That way this video gets to as many persons as possible, and we are encouraged to do more. Now, have you done that? Thank you. Let's continue. Draw the symbol for a NOR logic gate and complete the truth table for it. So that is the space for the drawing. So I'm just going to draw this with my touchpad. Okay, so don't expect a perfect drawing. So it has a curve like that, and then another longer curve. Because it's a NOR gate, you need the sign of the NOT symbol right there, and then minimum of 2 inputs. Then you have the output. Okay, so this serves as the output. So that is the symbol. That's basically how to draw it. So 2 curves, one shorter curve and then a longer curve, yeah, then with the NOT symbol in front of it. Okay, so we are asked to equally draw the truth table. Okay, so for the NOT gate, for the NOR gate, think of it as an OR gate with NOT gate in front of it. Okay, think of it as an OR gate with a NOT gate in front of it. So first things first, you need to do your OR operation before you now NOT the result. Okay, so 0 or 0 should be 0. When you NOT it, it should give you 1. 0 or 1 is 1. When you NOT it, you're going to have 0. 1 or 0 is 1. When you NOT it, you're going to have 0. 1 or 1 is 1. When you NOT it, you will have 0. Yeah, so I hope we're right. Yes, we are. So that's the way the NOR gate works. So the second part is this problem. So these are the 3 inputs, 1, 2, 3, and then these are the conditions and their description. So for 0 is dark, for 1 is light. Okay, and that follows for both the M and the S. So let's read. They say consider the rules given in the following table. So these are the rules. A security system uses sensors to sound an alarm if the intruder is detected. How do we know that the intruder is detected? The alarm sounding is represented by the output A equals 1. So for the alarm to sound, A needs to be 1. That is the output. Combining this in some ways has to give you 1. The alarm sounds if it is dark and if either motion or sound or both motion and sound are detected. Now take note of that. So we will do this carefully. Okay, we will do this carefully. So what I'm going to do is this. They say, so remember that the result has to give you a 1. Bear that at the back of your mind. So the alarm sounds if it is dark. That means for it to be dark, we're dealing with L, right? That is for dark or not dark, yeah? Okay, let's just write it that way. I will explain further. Let me take this down a bit. Okay. And so an AND gate needs to be there. And if either motion or sound. Now take note of that description. Either motion or sound, or both motion and sound are detected. So this description as a whole describes the behavior of the OR gate. Yeah, so whether M or S, so any of them being present will give you a 1. You understand? Okay, so we're going to write this here. M, in brackets, M or S. So either of them will give you a 1. That is what this very part of the expression is saying. If either motion or sound, or both motion and sound, so any of them that has a 1 will give you a 1. Now remember that the result that we want is to have a 1 at the end of the day. That is the condition for the alarm to sound. Okay, so L. Now for us here, they say L. So for L is if it is dark. So if you watch now, you will see that the darkness here is 0. So leaving this at days will result to 0 no matter what we do. So we need to negate this. So when we do not L and then in bracket M or S, we are setting that we're going to have A being equal to 1. So that's the idea to do this. You don't have to, make it long and do it separately, but you can if you want. But there's no need to do that because the OR gate alone is going to do that job for us. Okay, so I hope this is clear. So we're supposed to do that here. Okay, so we've moved it to this part where we're supposed to have it. All right. And then the last part is where we need to complete the truth table for the security system. So we need to complete this truth table using this very logic expression. So I like to break it down in parts so that we won't have any confusion. Okay. So what I'm going to do here, I will do not L. Okay. And then this part will be the M or S. Then here we can write the final thing. Yeah. Okay. So not L means you negate everything here. Okay. All right. So let's double check just to be sure that we're okay. For not L, remember it is for us to negate everything here. So that's 1, 1, 1, 1. So where you see 1, you put 0. Where you see any place you see 0, you put 1. You see 0, you put 1, and then where you see 1, you put 0. So that's the negation, not L. Okay, so the next part is for us to do M or S. So the idea is that for the OR gate, if any of them is 1, then the result is 1. If both of them is still 1, the result is 1. Only when you have 0 is if both of them are 0. Yeah? Okay. Okay, so let's double check just to be sure that we are okay. 0 or 0, 1, 1, 1, 0, 1, 1, 1. So double checking is very, very important because it is easy to make mistakes here. Okay, so the last part, what do we need to do? We now need to AND the result. So 1 and 0, 0, 1 and 1, 1, like that. So that's what we need to do now. Okay, so I think with this we are good. But however, you need to double check again. 1 and 0, 0, 1, 1, 1, 0, 0, 0, 0. Okay. Okay, so with this we're good, and then we'll answer the question. All right. Thank you guys for watching. Please do well to like, do well to share, to subscribe. Okay. That way this video gets to as many persons as possible. And if there's any question that you want us to treat, whether it's for IGCSE or for ASA level, please do well to let us know. Of course, I would find time to attend to it. Thank you guys, and I'll see you again in the next video. Bye for now.